Hello everyone, welcome back to my channel, and today we will together solve the daily LeetCode problem. And so for today's problem, we have the binary search problem, and why is that, and then I will explain it later. And then so our task today is that like we need to match the spell with the potion. For example, like in here for any kind of the given spell, and then we need to count how many elements of the potions. In here, for example, like we have the 4 elements, such as the multiplication between the spell and a given potion is greater or equal than the success, right? So in here, like we can see that if we multiply the first element in the spell, which is the 5, with all of the elements in the potions, and then somehow we will have this array, and then only the first element that is like smaller than the success, and then so we can conclude that like in this array we have 4 elements which satisfies the condition. So in here, like we can see that like for now we have the formula, which is like the spell by the potion, it needs to be greater or equal than the success, right? Okay, so firstly we can transform these conditions into another one. It means that like instead of multiplying the spell with the potions, because like this one will get the n by n, and then if we just doing that and then somehow like we that will be like the O, and that is will be the n square. And so in here, like we can see that for any given spell, and then somehow like sorry, for given potion, instead we can check about the conditions of like it will be greater or equal than the success divided by the spell, right? Okay, so this is our conditions. So in here, like how can we do that? Let's say that let's examine the first example, which is like for the potion, that is the 5, for example. And in here, like for the success, we are given the success, right? And the spell, I mean like for the first element in the spells, that is the 5. So it means that like somehow we need compare each element in the potions with the 7/5, that is like 1.4. Right, so it means that like in here we are given the potions which is 1, 2, 3, 4, 5, right? So in here we can see that like if the potions is shorted, and then somehow we only can find the first element which is greater than the 1.4, and then the rest of the element from the left to the right, starting from that index, let's say that this one is the index, will satisfy the conditions. And so here, let's say that in here the length of the array is 5, and then the index in here, that is the what? That is the 1, right? And then if we can find the first position in the array, and then we can conclude the length we need to append to the final results, that would be n minus index, right? That would be 4, right? That is the 5 minus 1, that is the 4. Okay, so how can we find this index? And then so here, let's say that we have the potions, which is a shorted array, and then our task is to implement a binary search, right? To find the conditions like the first element, which is greater or equal or 7/5 here. So we can do it by using the binary search, right? And then so to do the binary search, we have the maybe built-in or like the library in Python, that is the bisect left, which can help us to find the first index, satisfy the conditions. So we can use the bisect left, right, to do this one efficiently. Otherwise, I think that like we can implement it by ourselves, but in the industry, so it means that we need to use the library because of the reliability and also the time to market. So I strongly recommend you guys to make use of the available library. Okay, so that is the reason why in here we are using the binary search for finding the index in here, and with this index somehow like we can conclude about the final result we add to here, right? Okay, so only one exception in here is that what if the index in here, because what if we have the number, this one would be the number 6 for example, and then this index will be out of the range, right? It means that there's no there's no point in here can satisfy our conditions, for example, which is like there's nothing for us like for doing like divide by 6, and then yeah, so it means that there's no element in the portions can like can satisfy the condition, so we need to check that one. Okay, so let's implement it together. So I think firstly we just need to use the portions dot short, and then after that we can get the result as empty array. And so in here, like, let's define that the n will be the length of the portion. So for now, for each spell, and then we will check that like we need to find the insert index, right? That is the index we have over here. This is the insert index, because like bisect left indeed like it will find the positions for us to insert the number like this. For example, this would be like 1.4, 2, right? So it means that this 1.4 will be inserted in the middle between the 1 and 2, and that is the position 1, right? Okay, that is the bisect left. And so in here, like, we can use the bisect left. This one is the like binary search, and then so we can get in the portions, and then the finding parameters in here, that would be the success divided by the spell. And here, like, we will have two cases. The first one, if the insert index, if that one will be greater or equal than n, it means like it is our bound. It means that like we don't have any kind of the portion which satisfies our condition, right? So we will append 0 to the results. Otherwise, we just need to get the n minus index, right? In here, I mean that the insert index, and we finally we just return the result. Yeah, that's all the things we need to implement. Okay, so in here, one typos error. Okay. Yeah, so I think most of us have like the solution as me. So yeah, so I think that is pretty everything. And I also like did this one this morning, and yeah, so I think that like the most important thing in here, like we should make use of the available binary search library, and then somehow like we can maybe make use of that in our industry coding, or like in the daily coding as well. It will be help us to save a lot of the time. Yeah, so especially like if we just like join the weekly contest and we don't want to do the things like we implement the binary search by ourselves. But I think that like still somewhere like for us, like in the problem, let's say that in the problem in another hard questions, like this is also the weekly questions for the premium user, and then in this case we need to implement the binary search by ourselves. Otherwise, I just strongly recommend you guys to just like using the available one. If the logic, we can handle this by the available library. Yeah, I think that's all for today's problem. And yeah, thank you so much for watching my video. I know that I do not do any kind of the videos for the long time, because like recently I am busy with my side project, and also a lot of the project in the companies, which is like combination between the machine learning and the traditional algorithms. Yeah, I will be back soon, and yeah, of course, thank you so much for watching my video, and see you next time.